Welcome back. Now we shall discuss another special distribution called T distribution. And you can see that T distribution can be derived from a standard normal distribution and a chi-square distribution. Here you define t equal to x divided by root of y by n, where the numerator x follow a normal distribution, standard normal distribution, and y follow a chi-square distribution with n degrees of freedom. Okay, so the new random variable is actually a ratio of standard normal distribution to square root of chi-square distribution divided by its degrees of freedom. Okay, it is equal to x by t is equal to x by root of y by root n. Okay, and this random variable t is called t random variable and is said to follow the well-known t distribution with the parameter, or it is called degrees of freedom, n. Okay, and definitely you can see what is t when n is equal to 1, what is t when n is equal to 2, etc. Okay, so the t distribution definitely depend upon the degrees of freedom of the chi-square distribution. That means that as n changes, the shape of t distribution also changes. And you will see that this t distribution is a symmetric distribution about 0. T distribution is a symmetric distribution about 0. Okay, and you will see how it is derived. Derivation is somewhat simple by using the method of transforming two random variables x and y to another two random variables u and v, which you have discussed. We have discussed this thing in a earlier class, and you may please recall the procedure of finding the distribution of function of a random variable. Okay, here you see t is equal to x by root of y by n is a function, that is t is a function of x and y, and you can find another function of x and y. Okay, and that will be taken as t itself. This function is taken as t itself, and another function, instead of u and v, I am taking, instead of u I am taking t, and instead of v, okay, I can take some v also, and you will see in this derivation what is the v. Here you will see that v is nothing but y itself, but t is equal to x by root of x by y by n. Okay, in fact you can use capital T here. Capital T is equal to capital X divided by root of capital Y by n, and capital V equal to capital Y. But I take the value assumed by those random variables, that is why I am using the small letters. But here also I am using a small letter instead of capital letter, because I have to be inconsistent with the notations in literature. Okay. Okay, now x and y are independent as per the definition of t distribution. So what is the PDF of x? It is this: f of x equal to 1 by root of 2 pi e to the power of minus x square by 2, x in the range minus infinity to infinity, and y is chi square. So the PDF of chi square is 1 by 2 to the power of n by 2 gamma n by 2 e to the power of minus y by 2 y to the power of n by 2 minus 1 in the range 0 to infinity. You know these things. Okay, you may recall these PDFs. And what is the joint PDF of x and y? It is just the product of fx and fy because x and y are independent. So the joint PDF is this. What is this? It is equal to fxy equal to 1 by root 2 pi. This root 2 pi, I am taking 2 to the power of 1 by 2 here. Okay, 2 to the power of 1 by root 2 can be taken as 2 to the power of 1 by 2, and 2 to the power of 1 by 2 is written here, and I am combining these things. You need not combine it. Okay, for the time being, let me write so. And then gamma n by 2 e to the power of, you see here there is an e to the power of minus x square by 2, here e to the power of minus y by 2. So I am combining e to the power of minus 1 by 2 can be taken out, then leaving x square plus y inside the brackets, and then y to the power of n by 2 minus 1 is written as it is. Okay, y to the power of n by 2 minus 1 is written as it is, and the range of x and y is of course minus infinity to infinity, 0 to infinity. Okay, so this is the joint PDF. Okay, then you take the transformation techniques. You are having t is equal to x by root of y by n and v equal to y. So you can express x and y explicitly in terms of t and v like this. X is equal to t into root of v by n, and y is equal to v. Okay, so you take the Jacobian of transformation, that is dou x by dou t, dou x by dou v, dou y by dou t, dou y by dou v, determinant of these things, and you will see that it is equal to root of v by n. Okay, and what is v? V is a chi-square random variable because v is equal to y, therefore this is of course positive. So mod j is also equal to root of v by n. Okay, so the joint PDF of t and v, the transformed variables t and v, is ftv of tv, that is equal to 1 by root 2 pi 2 to the power of n by 2. ഞാനിവിടെ ഈ റൂട്ട് 2 നേരത്തെ ഇതിനോട് മിക്സ് ചെയ്തിരുന്നു, പക്ഷേ ഇവിടെ ഞാൻ വീണ്ടും പഴയതുപോലെ തന്നെ എടുക്കുന്നു. 1 by root 2 pi 2 to the power of n by 2 gamma n by 2 e to the power of minus 1 by 2 into x square plus y. S square means t square v by n plus y means v, because you have to write this PDF in terms of t and v using the PDF, joint PDF, this. Okay, into root of v by n because it is the modulus of the Jacobian. Okay, this is the joint PDF, and the range is very clear, minus infinity to infinity, because t will vary from minus infinity to infinity because t is equal to, what is t? T is equal to x by root of y by n. X ൻ്റെ റേഞ്ച് 0 മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി ആണ്, കാരണം എക്സ് സ്റ്റാൻഡേർഡ് നോർമലാണ്. അപ്പോൾ അതുകൊണ്ട് ടിയുടെ റേഞ്ചും മൈനസ് ഇൻഫിനിറ്റി ടു ഇൻഫിനിറ്റി ആയിരിക്കും. വിയുടെ റേഞ്ചോ, വി എന്ന് പറയുന്നത് y ആണ്, y എന്ന് പറയുന്നത് കൈ സ്ക്വയർ ആണ്, അതിൻ്റെ റേഞ്ച് 0 ടു ഇൻഫിനിറ്റി ആണ്, അതുകൊണ്ട് വിയുടെ റേഞ്ച് 0 ടു ഇൻഫിനിറ്റി ആണ്. ഓക്കെ, സോ ദിസ് ഈസ് എ PDF. ഇനി മാർജിനൽ കാണാം. നമുക്ക് ടിയുടെ ഡിസ്ട്രിബ്യൂഷനാണ് കാണേണ്ടത്, അതായത് ടിയുടെ മാർജിനൽ ഡിസ്ട്രിബ്യൂഷൻ. ടിയുടെ മാർജിനൽ ഡിസ്ട്രിബ്യൂഷൻ എന്ന് പറയുന്നത്, വാട്ട് ഈസ് ദിസ്? ഇറ്റ് ഈസ് ദി ജോയിൻറ്റ് PDF, integral of the joint PDF with respect to v over the range v, that is over the range 0 to infinity. So you will have a constant you can taken out, then integration 0 to infinity e to the power of minus 1 by 2 into 1 plus t square by n into v. അതിവിടെ ഈ ക്വാണ്ടിറ്റി നമുക്ക് v പുറത്തെടുത്താൽ നമുക്ക് സിംപ്ലിഫൈ ചെയ്യാൻ പറ്റും. വി പുറത്തെടുത്ത് കഴിഞ്ഞാൽ ഇവിടെ മൈനസ് 1 by 2 ഇൻറ്റു വി ഇൻറ്റു ടി സ്ക്വയർ ബൈ എൻ പ്ലസ് 1 വരും. അതാണ് ഞാനിവിടെ എഴുതിയിരിക്കുന്നത്. ഓക്കെ, ഇൻറ്റു വി ടു ദി പവർ ഓഫ് എൻ പ്ലസ് 1 by 2 മൈനസ് 1, കാരണം ഈ ക്വാണ്ടിറ്റി, അതായത് റൂട്ട് ഓഫ് വി, അതുപോലെ റൂട്ട് ഓഫ് എൻ ഡിനോമിനേറ്റർ, ഇതെല്ലാം കൂടി കമ്പൈൻ ചെയ്യുമ്പോൾ നമുക്ക് ഇവിടെ ഒരു n ടു ദി പവർ ഓഫ് 1/2 പുറത്ത് വരും. അതായത് ഇവിടെ ഉള്ള റൂട്ട് എൻ, ഡിനോമിനേറ്ററുള്ള റൂട്ട് എൻ ആണ് ഇവിടെ ഈ n ടു ദി പവർ ഓഫ് 1/2 ആയിട്ട് വരുന്നത്. ബാക്കിയുള്ള ക്വാണ്ടിറ്റിയൊക്കെ നമുക്ക് വളരെ ക്ലിയർ ആണ്. ഓക്കെ, ഇൻറ്റു ഇൻ്റഗ്രൽ 0 ടു ഇൻഫിനിറ്റി e ടു ദി പവർ ഓഫ് -1/2 ഇൻറ്റു സംതിങ് ഇൻറ്റു വി ടു ദി പവർ ഓഫ് n+1/2 - 1 dv. നോക്കൂ, ഇത് ഒരു ഗാമ ഇൻ്റഗ്രലാണ്. കാരണം ഗാമ ഇൻ്റഗ്രൽ എന്ന് പറഞ്ഞാൽ 0 ടു ഇൻഫിനിറ്റി, ഇൻ്റഗ്രൽ 0 ടു ഇൻഫിനിറ്റി e ടു ദി പവർ ഓഫ് -θ ഇൻറ്റു വി ടു ദി പവർ ഓഫ് p-1. നമ്മൾ നേരത്തെ ഡിസ്കസ് ചെയ്ത ഗാമ ഡിസ്ട്രിബ്യൂഷനുമായിട്ട് ഇതിനെ ഐഡൻറ്റിഫൈ ചെയ്ത് കഴിഞ്ഞാൽ ഇതിൻ്റെ വാല്യൂ ഗാമ p ഡിവൈഡഡ് ബൈ θ ടു ദി പവർ ഓഫ് n+1/2. Okay, then you can simplify these things and many of the quantities will be combinedly, nothing will be cancelled. You can take the gamma n+1/2 in the numerator, then gamma n/2 is there in the denominator, and here root of pi is written as gamma 1/2. That is a well-known result. Root pi is equal to gamma 1/2. You please remember this result. Root pi equal to gamma 1/2. Okay, so you will get this quantity. Okay, you will get this quantity, and you can see that this constant. What is this? This is gamma n/2 plus 1/2 divided by gamma 1/2 into gamma n/2. That means it is the reciprocal of beta of 1/2 n/2. Okay, yes, we have discussed this quantity in beta function or beta integral. So that is equal to 1 by n to the power of 1/2 into 1 by 1 plus t square by n to the power of n plus 1/2 in the limit minus infinity to infinity, because limit of t is minus infinity to infinity. So you are finding the PDF of t, that is PDF of t distribution. Okay, and we define now t distribution in terms of its PDF. Okay, how would you define now a t distribution with n degrees of freedom? A continuous random variable t is said to follow a t distribution with n degrees of freedom if its PDF is f of t equal to 1 divided by beta of 1/2 n/2 n to the power of 1/2 1 by 1 plus t square by n to the power of n plus 1/2. Okay, such a distribution is called t distribution with n degrees of freedom. Okay, and you will write this distribution t follow a, this is the notation used, t follow t distribution with n degrees of freedom. Actually this is this distribution is called Fisher's t distribution. Okay, student t distribution is there, that we will discuss later when we come to the sampling distribution. Okay, and you will see what happens when n is equal to 1. That is a special case of t distribution. And when n is equal to t, you substitute n is equal to 1 in your t distribution, and you will see that it is equal to beta of 1/2, then 1/2 to the power of 1 to the power of 1/2, that is 1, then 1 plus t square by 1, that is 1 plus t square to the power of 1 plus 1/2, that is 1. So finally you will see that this is equal to f of t, it is equal to 1 by beta of 1 by 2 1 by 2 into this, and you will see that this is nothing but 1 by pi, because you will see that this pi, because here you will see that there is a gamma 1 by 2 into gamma 1 by 2, okay, that is root pi into root pi, that is equal to pi, then 1 by 1 plus t square, and all other terms will vanish, because gamma 1 by 2 plus 1 by 2 is nothing but gamma 1 is 0 factorial, that is 1. So in this way you will see that this is the PDF of t distribution with n is equal to 1, and you can identify this distribution as standard Cauchy distribution. This distribution is called standard, the distribution with this PDF is called standard Cauchy distribution, okay. And you have to remember that the connection between t distribution and Cauchy distribution is this. Cauchy distribution is a special case of t distribution when degrees of freedom of chi-square distribution in the definition of t distribution is 1, or Cauchy distribution, standard Cauchy distribution is the t distribution with 1 degree of freedom, okay. And you can see now the moments of t distribution, how the moments of t distribution are determined. As I have already told you, t distribution is a symmetrical distribution about 0. So the odd order moments will be vanishing, as in the case of normal distribution. Odd order moments will be vanishing because of this symmetry about 0. And therefore mean is equal to 0. And all odd order moments, the even order moments are computed like this. You can take this mu 2r dash. Mu 2r dash means it is an even order moment, because when r is equal to 1 you have a mu 2 dash, when r equal to 2 you have mu 4 dash, when r is equal to 3 you have mu 6 dash, and so on. Therefore these are even order moments, okay. And you can compute this from minus infinity to infinity integration t to the power of 2r f of t dt. That is the plain definition of mu 2r dash. And you know f of t, what is f of t? F of t is this, okay. F of t is an even function. Why it is an even function? An even function in t, because it is t square, okay, and all other terms are not depending on t. Therefore this function f of t is an even function. An even function, what is an even function? G of x is even if g of minus x equal to g of x. Here f of t and f of minus t are same, therefore it is an even function, okay. And similarly t to the power of 2r is also an even function, so their product is an even function. And integration of an even function in the range minus infinity to infinity is nothing but 2 times 0 to infinity of this, okay. So this is equal to 2 into 1 by beta to the power of 1 by 2 n by 2 root n integral 0 to infinity t to the power of 2r divided by 1 plus t square by n to the power of n plus 1 by 2 dt. And you integrate this using a substitution procedure. 1 by u is equal to 1 plus t square by n, and integration will yield these things. And the range will become, when t is equal to 0, u is equal to 1, and when t is equal to infinity, u equal to 0. That means the integration from 0 to infinity becomes what? 1 to 0. 1 to 0. But there is a negative quantity here. So the integration range will be interchanged. So the integration becomes 0 to 1. Right? 0 to 1. Then you make the substitution here, and again you come to this, and you will see that dt is nothing but this quantity, and on integration with a little effort you will put in this final form, of which this is a beta function. This is a beta function of the first kind. Okay, and since this is the beta function of a first kind, what is the value of this? The value of this is in the form y to the power of alpha minus 1 into 1 minus y to the power of beta minus 1. Okay, so you will have the integral is equal to beta of n by 2 minus r plus 1 by 2. Okay, and you know how this beta 1 by 2 n by 2 and beta n by 2 minus 1 r plus 1 by 2 can be simplified, and on simplification you will see that this is n to the power of r into gamma n by 2 minus r gamma r plus 1 by 2 gamma 1 by 2 divided by gamma 1 by 2 into gamma n by 2. Okay, this is the expression for the second order moment, fourth order moment, sixth order moment, etc. That is, even order moments can be determined using this formula. So you can come to some particular cases. You can put r is equal to 1, so that you will get mu 2 dash. Okay, mu 2 dash is equal to n divided by n by 2. Okay, and mu 4 dash, it is equal to this for n greater than 4. Here for n greater than 2, because when n is equal to 2, denominator becomes 0, it becomes indeterminate. So the quantities should be positive. That is why we are restricting this n greater than 2. Similarly, we are restricting n greater than 4 for making the denominator always positive. Okay, so the mean is equal to 0, because you know all odd order moments are 0, and variance is equal to n divided by n by 2. Variance, what is variance? Variance is equal to expectation of x square, that is n by n minus 2, minus expectation of x the whole square, that is 0 square. So this is variance. So this is the mean of t distribution, and this is the variance of t distribution. Right? Okay. And you should note a very important point here. You have the mean equal to 0 and variance equal to n by n minus 2 only if n is greater than 2. N is greater than 2. That is, when n is equal to 1 and when n is equal to 2, no variance exists for t distribution. So t distribution will have mean equal to 0 and variance equal to n divided by mean equal to 0. It is always true, but variance is equal to n divided by n minus 2 only if the degrees of freedom is greater than 2. That is a very important point to note about t distribution. Okay, and you are finding the moments. You can find mu 1, mu 2, mu 3, mu 4, etc. because you have found that here mu 2 dash, mu 1 dash, mu 3 dash, mu 4 dash, etc., where mu 1 dash equal to 0, mu 3 dash equal to 0, and so on. So using this, you can find the row moments. You can use the row, you can find the row moments, and the row moments will be these things, and you will see that beta 1 is equal to 3 into n minus 2 divided by n minus 4, and that is equal to 3 into 1 minus 2 by n divided by 1 minus 4 by n, and you will see that this tends to 0 as n tends to infinity. Okay, that is the beta 2 coefficient tends to 3 as n tends to infinity. Okay, and similarly beta 1 is equal to 0 and beta 2 is equal to 3 as n tends to infinity. That means as n tends to infinity, the skewness measures becomes 0 and 3, because beta 1 and beta 2 are the skewness measures, and these are actually the properties of a normal distribution. Okay. Now these are the things regarding t distribution, and you recall we have discussed the mean of t distribution, variance of t distribution, and the variance exists only when the degrees of freedom is more than 2. Okay, and you have found how the normal the t distribution is derived, and how the moments are determined. Okay, the moments are determined, and all these things are derived using the gamma integral and beta integral. That is why we were discussing these integrals earlier. Okay, thank you.